In this last section in Chapter 2, today we're going to take a look at density. By definition, density is the mass of substance per unit volume of that substance. And the most common units that we're going to look at are grams per cubic centimeter or grams per milliliter. And if you remember, grams per cubic centimeter and grams per milliliter are the same thing. A cubic centimeter and a milliliter are an equivalent. So our formula is going to be density equals mass over volume. You need to keep this in mind and remember this. Write it on your magic chart so you have it for the test. There's different ways to measure density. Mass is easy to measure. You just put something on a scale. But volume, on the other hand, is different. Now, we are used to using volume measurements when we look at cubes and things like that because that's what you're familiar with in math class. But in chemistry class, sometimes we don't deal with objects that have a definite fixed volume that's easily measured. So in this case, if we have an irregular shaped solid, such as a human, for example, we could measure the volume by a method called water displacement, and you'll experience this in the lab as well. So we take a known volume of water, and we put the object in the water, and we record the new volume, and then we subtract the difference between the two because whatever volume difference there is the volume that that body or that object took up inside of that particular tank. Let's look at an example. This says a certain mineral has a mass of 17.8 grams and a volume of 2.35 cubic centimeters. What is the density of this material? And we're going to start off with looking at what the formula is. And let's go ahead and show that. Density is mass over volume. So we need to keep that in mind when we're doing the problem. Now we need to write down the information that we have, and we need to be very detailed about it and very orderly about it. This is going to be the way we do all of our problems so that it's easy for us to figure out what information we have and what information we need. So let's go through here. It says a certain mineral has a mass of, so we have mass, and that's going to be 17.8 grams, and a volume of, so let's write volume, 2.35 cubic centimeters. What is the density? So density is what I want to know. So in this case, this is the easy plug-in. We have density equals mass, which is 17.8 grams, over 2.3, I'm sorry, it's cubic centimeters, 2.35 centimeters cubed. You're just going to take that and plug it into your calculator as 17.8 divided by 2.35. And my final answer is 7.5744 grams over cubic centimeters, or grams per cubic centimeter. Now let's look at sig figs. We have 3 in this one and 3 in this one. We're doing a division problem, so I keep the same number of sig figs as the least number in my problem. Since they both have 3, I should keep 3 in my answer. So here's 1, 2, 3. I look at this place. Is it 5 or larger? No, so we're going to keep the 7. So our final answer is going to be 7.57 grams per cubic centimeter. And go ahead and draw a box around it, and that helps you identify where your answer is. Let's look at a second example, and let's go ahead and start with writing down our formula again. You see part of it down here. It's density equals mass per unit volume. Okay, so let's write down the information that we have. It says, what is the mass of, so here, first of all, M equals a 49.6 milliliter sample of a liquid, so volume equals 49.6 mils, which has a density of 0.85 grams per milliliter. All right, so in this case, we know density, and we know volume, but we have to find mass. You are already in Algebra 2 or have taken Algebra 2, so you are proficient at using formulas from Algebra 1. So this is just simple variable manipulation and the use of a formula. So I'm going to do this by plugging in the information that we do have. So let's start by plugging in density, which is 0.85 grams over milliliter, 1 milliliter. We can write it like this to help us out here with the manipulation. Mass, I don't know, Volume is 49.6 milliliters. I need to solve for mass. So the easiest way to do this is to cross multiply. So I'm going to take 0.85 grams and I'm going to multiply that times 49.6 milliliters and set that equal to, so it's that times that, that times that, so 1 milliliter times the mass. I divide both sides by 1 milliliter to make sure that I get rid of my units. And this, so the answer that I get is going to be 0.85 times 49.6 and then divided by 1. So it's 42.16. The only unit I have left because I cancel milliliters is grams, which is great because that's what I needed for mass. And I have 2 sig figs here. I have 3 sig figs here. I'm multiplying and dividing, so I can only keep 2 because I have the least number in my problem to start with. So my final answer would be 42 grams as my final answer. It's important and essential that I see your work worked out this way so that I can tell that you actually know what you're doing. It's not just chance that you ended up with the right answer. I have to see that you manipulated your variables and your numbers correctly. It takes a lot of practice. You have to be patient, and you have to make sure that you can write to where I can read it. So let's take a look at another problem. If an object has a mass of 243.8 grams and occupies a volume of 0.125 liters, what is the density of this object in grams per cubic centimeter? Let's get started on this one. Let's write down the information we do have. Has a mass of, so mass equals 243.8 grams. And occupies a volume of 0.125 liters. What is the density in grams per cubic centimeter? All right, so we have a couple of different ways we can look at this. We can calculate the answer and then do the conversion, or we can do a conversion first. I like to do the conversion first so that you see that you made that conversion and it's at the beginning and get it out of the way. I want it in grams. This is already in grams, so we're good there. But this is in liters, and they want it in cubic centimeters. So what you need to do is change liters to cubic centimeters. Now remember that a cubic centimeter is the same thing as a milliliter. And if you go to your stair step, there are 1,000 milliliters in 1 liter. If you didn't know this already, you would have to go to conversion factors and find what that is before you do your conversion. So let's go ahead and just do our conversion here. 1 liter is going to go on bottom so that our liters cancel, and 1,000 milliliters is going to go on top. So we take 0.125 times 1,000, which is just going to move that decimal point 3 places to the right. We have 125 milliliters, or remember, that's the same thing as 125 cubic centimeters. Same exact same thing. So now we go ahead and plug it in our formula. We know the density is mass over volume. So mass is 243.8 grams. Density is mass divided by volume. So volume is 125 milliliters or 125 cubic centimeters. So 243.8 divided by 125 is 1.9504 grams over cubic centimeters. We have 4 sig figs on the top, 3 on the bottom, so we're going to keep 3. So 1, 2, 3, this is a 0, so it's going to remain a 5 before it, so 1.95 grams per cubic centimeter, and that's your final answer for that problem. All right, let's look at one that's maybe a little bit more difficult. Copper has a density of, let's just write that down, density is 8.96 grams per cubic centimeter. If 75 grams of copper, so here's our mass of copper, 75 grams, is added to 50 milliliters of water in a graduated cylinder, to what volume reading will the water level in the cylinder rise? Remember with the example earlier with the girl in the water cube where we displaced to find out what her volume would be, we're going to do the same thing here with the copper. So we have a graduated cylinder this time instead of that big tank like she was in, and it's got markings on it. And what it's saying is I already have water up to the 50 milliliter mark. And I want to know if I drop that copper into this water, what volume it's going to read after the copper is added to it. The only way to figure that out is to find out what volume the water takes up. And we can do that mathematically because we're given density, we're given mass, and we can find volume. So let's start with density. We're going to use our D equals M over V again. So 8.96 grams over 1 cubic centimeter equals 75 grams over X, which is our volume. Cross multiply 8.96 grams times X equals, I'm going to cross multiply this way, 1 cubic centimeter times 75 grams. We're going to divide both sides. It's just basic algebra. Divide both sides by 8.96 grams. That's going to get rid of that. 8.96 grams. That's going to get rid of our grams. We're going to do the math. So 1 times 75 divided by 8.96 is 8.3705. And my unit that's left over is cubic centimeters. So that's the volume that that piece of copper takes up. Let's get our sig figs right. We have 3 here, we have 2 here, so we're only going to keep 2 in our answer. So there's 1, 2. We look at this, it's larger than a 5 or larger, so we're going to round up. So it's going to be 8.4 cubic centimeters is the volume. That's not what the question asks for, though. We have to have that to answer the question. But it says if that's added to 50 milliliters of water, what volume is going to be read, or what level will it rise to once it's added? So we're going to take the 50 milliliters, and we're going to add the volume that it should take up, which is 8.4 centimeters cubed, or milliliters, because remember milliliters and centimeters cubed are the same thing. I'll just change this to milliliters real quick. This is 58.4 milliliters. And this is your final answer. That is the volume inside the graduated cylinder. That's going to finish up the chapter. That's the last math that we have to do in this chapter. We're going to conclude this with a density lab that's going to help you understand what density is as well and how we can continue to manipulate it mathematically to get the information that we need for our chemistry class.